Alrighty, this is going on page 87 when we're done. Okay. So arc length is something that you do see in geometry. The difference between the arc length you did in geometry and the arc length that we are doing here is that in geometry it's all based in degrees, and what we're doing is based in radians. Okay. So we have a circle here, right? This is the center of my circle. So this is the radius because it's the same all the way around, right? This theta is the central angle, called a central angle because the vertex is at the center of the circle. It sections off part of the circle, which makes an arc. And so there's my arc right there. The length of the arc is denoted by a lowercase s. Okay? Why it's an s, I don't know, it just is. And then r for radius, okay? So even in geometry, when you do this and it's related to degrees, there's a formula that you would see on a formula chart or your textbook, but it's not something that when I taught it that way 1 year and then I never showed them the formula again because the formula is a little intimidating. R's for radians ends up being different. You'll see why in just a minute. But either way, it's just a proportional relationship, a part out of the whole, right? So this S is a piece of the distance all the way around. What's the distance all the way around? No. The distance. What do we call the distance all the way around a circle? Circumference. So an arc length is just a part of the circumference. Make sense? Theta is an angle out of how many total radians as you go around? 2 pi. Because 360 degrees are 2 pi radians. So you got the arc out of is a piece of the circumference. Theta is a piece of the 2 pi. Make sense? Simple proportion. I know you've been doing proportions forever. So that gives me, let's say, S over the circumference equals theta over 2 pi, right? Part out of the whole, part out of the whole. Make sense? Okay, so now I'm going to cross multiply, and I'm going to multiply S times 2 pi, so I get S times 2 pi equals C times theta. We're all good with all that? All right, so then what is the equation for the circumference of a circle? 2 pi r. What is the formula for the area of a circle? Pi r squared. Those are two formulas you have to know. You know, I told you on the AP test, they will give you some formulas, not all. They'll give you the formula for the volume of a cone. They're not giving you this. You've been doing this since 6th grade. Okay? And look, there's 3 things. You just have to put them in the right order. 2 pi r or pi r squared. Where does the 2 go, right? Units are squared for area, so we square it, okay? So if I did, so let's say my radius was 10 feet. Then I would square that. That's where I get feet squared from. For the circumference, it would just be feet because it's just a distance. Even though this is a 2-dimensional picture, it's a 1-dimensional measurement because I can like cut the circle and roll it out and all I have is length. You with me on that? Okay. The other thing is whether letters are lowercase or capital, especially for geometric figures, they make a difference. It's not just you can write whatever you want. Most of the time, like when we're using our triangles ABC, the capital letters are the points or the angles. The lowercase letters are the side lengths, right? So here we have lowercase r for radius, lowercase s for this length right here. But the C and the A are capital. Not just they're not points and they're not angles, and not just because we willy-nilly wanted it to, but it's a calculated value, and that's what makes it a capital letter also. Okay, so those things make a difference. All right, so now that I know this, I can take the circumference, which is 2 pi r, right, and I can substitute it in right here where the circumference goes. So that means I'm going to get S times 2 pi equals 2 pi r instead of C times theta. You agree with that? I have one term on each side, but on both sides here, I have a 2 pi, right? So I can divide both sides by 2 pi. Those cancel, and that leaves me with S equals r theta. The reason the degree version looks worse is that this right here would be 360 instead of 2 pi, and then you can't cancel them out, and there's just more stuff in there. And the way they write it is like with a fraction. It's not a pretty formula to begin with, okay? But our arc length formula, very simple. Arc length is equal to the radius times the angle, right? So that's what we can put right here. S is equal to r theta. And remember, theta is the central angle. That means the vertex is at the center of the circle, intercepted arc, and this is where theta is measured in radians. So that formula only works if we are in radians. Okay? We're all good so far? Alrighty. So let's look at number 1. It says in a circle with radius of 3 feet, an angle measuring 5 pi 6 radians, intercepts an arc, find the length of the arc in simplest form. All right, so I want the length of the arc. That's S equals, my radius is 3 times the angle, which is 5 pi 6. Okay? Now, we're going to talk calculator in just a minute, but we're going to do this one without a calculator. Because on some of these, it's just going to be easier for you to do it without a calculator. You've got to trust me on that. Plus, you need to be able to do it without one. So I can, because I'm multiplying, I can reduce before I multiply. And just so that we're all clear when we cancel things like this, when we're canceling like this, that is not the same thing as cross multiplying. Those are two completely different things. You are cross multiplying when you go across an equal sign. Here, I would just be reducing, like if I thought about this as 3 over 1, and I could just look at it as one big fraction. So 3 goes into 3 once, goes into 6 twice. So my arc length is 5 pi halves. And what are my units here? Feet. It's like perimeter. Easy enough? It's really a basic little concept that we just need to know to do the next thing that we're doing. All right, number 2. I have a radius of 22 inches, an angle measuring pi 4 radians. Find the length of the arc. All right, so S equals the radius, which is 22, times the angle, which is pi 4. So this is another super easy one to do without a calculator, but we'll talk about the calculator a little bit. Would you agree that what I have written here is the same thing as 22 times 1/4 times pi? That's the same thing, right? I wouldn't expect you to write it that way, but if I multiplied it all together, it would look like that. Because your answer is going to have pi in it. We want an exact answer here. So if I'm going to use the calculator, I am not pushing the pi button because it'll give me a decimal and it will not undo it because it's not a rational number. So if you're going to use the calculator to help you with this, you leave the pi out, like right here, but you can't forget to put it back. So in your calculator, I want you to do 22 times 1/4, ignore the pi. You get 11 halves, correct? If you just write 11 halves, you are wrong. It has to be 11 pi over 2. You got to put that guy back in, okay? But I would say, especially on this one, it's easier just to do it. You're not having to waste time to push buttons and whatnot, okay? We good? Any questions? Okay. Number 3. In a circle, we have an angle measuring 3 pi radians and an arc length of 3 pi eighths. We want to find the radius of the circle in simplest form. All right, so we know the arc length, that is 3 pi eighths. That's equal to the radius, which we don't know, times the angle measure, which is 3 pi halves. I want to get r by itself. What's the opposite of multiplication? Bless you, division. How do you divide with a fraction? Multiply by the reciprocal, right? So if I want to get rid of this, I can multiply both sides by 2 over 3 pi. Multiply this by 2 over 3 pi. So those cancel out. These 3 pi's cancel out. I'm left with 2/8. What's 2/8 reduced to? 1/4. And it was easier just to do it without worrying about the calculator. What questions you got? All right, let's look at number 4. In a circle, an angle measuring 15 degrees intercepts an arc length of 2 pi thirds. We're looking for the radius again. All right, so our arc length is 2 pi thirds. It's equal to the radius that we don't know times the angle. Can I put 15 in there? No, why not? It's not in radians. This formula only works when it's measured in radians, okay? So that means I can't just plop 15 in there. I've got a couple of options. I can use my conversion formula, or I can use a little bit of logic. Let's use a little bit of logic here. What is 30 degrees in radians? Pi 6. So then what is 15 degrees in radians? Pi 12ths. See how easy that is? Okay. So r times pi 12ths. I need to get pi 12ths away, so I'm going to multiply it by 12 over pi. 12 over pi. The pi's cancel out. Those cancel out. 3 goes into 12 4 times. So r is equal to 8 feet. What questions do you have? Anything? All righty. Number 5. In a circle with radius 9 meters, an angle intercepts an arc length of 6 pi meters, find the angle in radians in the simplest form. All right, so we have the arc length. It's 6 pi. And then that's equal to the radius, which is 9, times theta. What do I do to get theta by itself? Divide by 9. Theta equals 6 pi divided by 9. And theta equals 2 pi thirds radians. So radians is one of those things that sometimes we use the units, sometimes we don't. It's one of the very few things where it's acceptable to leave the units off. So, because if you know it's an angle, it's just kind of known that that's what it is. Okay. Right, because it's only yes. All right. Anything else? So 2 times 12 divided by 3, or the 3 cancels with the 12, and this becomes 4, and you have 4 times 2. Either way. All right, so the next one says, in a circle with radius 18 inches, intercepts an arc length of 27 pi over 2, find the angle. So same kind of question, but there's a reason I'm doing this one too. So the arc length is 27 pi over 2. And that equals the radius, which is 18, times the angle that we don't know. Okay, so I need to divide both sides by 18, right? And if I literally just divide, then that's a fraction and a fraction, which isn't the end of the world, especially with the calculator. But if I didn't have a calculator, I may not want to make it that complicated for myself. So dividing by something is the same as multiplying by what? The reciprocal. So if I multiply both sides by 1 over 18, and if you need to write that as a fraction as 18 over 1, that's totally fine. 1 over 18, so those cancel out. And then, let's see, these are both divisible by 9, so that becomes 2, that becomes 3. So theta equals 3 pi fourths radians. What questions do you have? We good? All right. Now we have a merry-go-round. So the merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So that how far, that's going to be like an arc length. So here's a merry-go-round. Right? Here's my little rider. And they are seated 8 feet from the center. That's my radius, right? If they're going to rotate 2,808 degrees, are they going around more than once? Yes, they're going around quite a few times, right? But that's still a length. It's just, it's just like a lap, how many laps you made, that's how far you've run or whatever. And so I can go ahead and set this up and say, all right, so I'm looking for the arc length. That's equal to the radius, which is 8 times the angle, but do I get to use 2,808? No, because that is not in radians. Now, we used logic last time. Is logic going to work for us this time? No, probably not, right? So we need to know how to convert. 2808, what do we multiply by to convert from degrees to radians? Pi over 180. Because we multiply, because that's your ratio, right? Pi is 180. So pi over 180 or 180 over pi, if you're trying to get it into radians, the radian part's on the top. And so this one for sure, should we be able to do it by hand? Yeah, but use your calculator and see what we get for theta here. Is theta 78 over 5? Yes? How about no? What's theta? Thank you, 78 pi over 5. You have to put pi back in there if you're going to use the calculator. All right, so it's 8 times 78 pi over 5. And then you can go ahead and multiply that. And what do we get? 624 pi over 5. This is a story problem, so we need to say a writer seated 8 feet from center of merry-go-round travels 624 pi over 5 feet during the ride. Now, this is, we want exact answers here. But we have exact answers and then what I usually call like Home Depot answers, right? Like if they were going to put a travel brochure out or they're advertising their theme park and it says, hey, when you get on this, you're going to travel 624 pi feet on this ride. Like that doesn't make any sense to just the average human. I mean, that doesn't necessarily even make a whole lot of sense to me about how far that really is. But it's our exact answer. If we needed to put it in some publication, we would round it so it makes more sense to everybody else. Okay, but we'll just leave it exact for now. We good? All right. Last one then. So the central angle theta in a circle, radius 6, is an intercepted arc length of 10 meters. Find the measure of theta in radians and in degrees. All right, so the arc length, which is 10, equals the radius, which is 6, times theta. So I'll divide both sides by 6. I get that theta equals 10 over 6. So theta equals 5/3 radians. Does it look like something's wrong with this answer? What looks wrong? There's no pi, okay? So you have to decide then, is that because we forgot to put it back in, or does it not need to be there? What do you think? It doesn't have to be there, because if you look back at 5 and 6, the arc lengths that they gave us have pi's in them, right? Which makes sense because of the way that we're finding them with exact answers. This arc length doesn't have a pi. Let's say that you were going to make a circle out of a piece of string. Are you more likely to measure out exactly 10 inches, or would it be like, 5 pi inches? Like if you're going to measure, we're probably going to measure 10. You can totally have a circumference, or the arc or whatever, of 10 inches. Does that make sense? So it's fine that it's exact. That happens. And so we're used to seeing our radians with pi's. This one doesn't have it, and that's okay, right? It's just calculated in there, really. All right, so that's in radians. Then we need to do it in degrees. So your theta is equal to 5/3. That's radians. I want degrees. What do I multiply by? Try again. 180 over pi. Okay? And so then what does that mean? That, let's see, 3 goes into 3 once, goes into 180 60 times. 5 times 60. Theta is equal to 300 over pi degrees. Now, let's talk about this answer. If I leave it like this, that degrees is really just on 300. So it's like, oh, it's a 300-degree angle that we then divide by pi. That's why you see parentheses around a lot of fractions. That way, whatever's on the outside of it goes to that whole fraction. The angle measure is 300 over pi degrees. Okay, those are two different things. We good with that? And that's a weird looking angle too, but weird is not wrong necessarily. What do you mean divide it? Exact answers. There should not be any decimals. You should not need a calculator at all. Like, I'm letting you use it because some of the numbers are weird and we don't want to miss it because we make a stupid mistake, but you don't actually need it, so you wouldn't be able to do that. Okay? Anything else? Alrighty. Your assignments in Delta Math.